Hello, this is Elizabeth Shimagawa from the Academic Support Center at Raritan Valley Community College. And I have a quick lesson here on quadratic functions. So the general form for a quadratic function is f of x is equal to ax squared plus bx plus c, where a isn't equal to 0. If a is equal to 0, this term becomes 0. We just have bx plus c, and that's the equation for a line. So as long as we have an x term squared here, we have a quadratic function. Quadratic functions look like parabolas. So I have two examples here. One, this parabola is opening upwards, so it looks like a U. Whenever a is greater than 0, we have a parabola that's opening upwards. A is greater than 0. When a is less than 0, we have a parabola that opens downwards, like this one over here. Okay. This point where it changes at the tip of our parabola, where it goes from decreasing to increasing, this is called our vertex. Okay, I'm just going to bring this, I have these terms over here. As we talk about it, I'm going to add these to our graph. So this is our vertex. It doesn't matter if it opens upwards or downwards, this point where it changes is called our vertex. Okay. We also, the way we find our vertex, we have an equation for our vertex, and that's negative. The x value of our vertex is going to be x equals negative b divided by 2a. So we take the coefficients from our quadratic formula, we can plug it into this equation. And the ordered pair is going to be negative b over 2a. And to find the y value, we're just going to plug this back into our function. So f of negative b over 2a. So that's going to be our vertex. That's how we find our vertex. When we have a parabola that opens upwards, sometimes we talk about the minimum. Okay, the minimum purely is the y coordinate of our vertex. Okay, so vertex, the y value is going to be a minimum. When we have one that opens downward, this is our maximum. Okay, usually when we talk about minimum and maximum, we're looking for the y coordinate of our vertex. Okay, but it is that vertex point where we have our minimum and maximum. You can see that that minimum is the lowest y value. So the domain of any quadratic function, we can plug any x value into here. The domain is negative infinity to infinity, but we do have a limit on our range. So we're going to go from our minimum to infinity, or from negative infinity to our maximum. This portion of the graph here, if we were walking along a road, we would be going downwards. This part of the graph, we say that this is decreasing. Okay, so we're going to be decreasing until we get to our vertex. Once we get to our vertex, it turns, and then we are increasing. Okay, same thing here. If we walk along with our downward pacing parabola, if we walk along this part until we get to the vertex, our y values are going up, so we say that this is increasing. And once we get to the vertex, we turn, and then we're decreasing. Okay. The final thing that we need to know about parabolas is that there's an axis of symmetry. The axis of symmetry, is a vertical line that passes through. How come I want to copy this? Just this. Yes. A vertical line that passes through our vertex. It's not part of the parabola, but that's our axis of symmetry. And same thing here. We have an axis of symmetry. Okay, it's a vertical line that passes through our vertex. It's called the axis of symmetry. So if we folded that parabola along that axis of symmetry, it would match up. It's the same on either side. Okay. So that's the basic terminology, and we're going to walk through an example. So I have an example down here. this is our f of x is equal to negative x squared plus 2x minus 8. So first thing that we want to find is we want to find our vertex. So we're going to remember this formula that is negative b divided by 2a. In this case, our b is 2, so negative 2. Our a here is, there's no coefficient, which means it's a 1. So 2 times 1. This is equal to negative 2 over 2, or just negative 1. So that's the x coordinate of our vertex. To get our y coordinate, again, we have to plug that negative 1 back into the equation. So we're just going to do that. Wherever we see x, we're going to put negative 1. Negative 1 squared plus 2 times negative 1 minus 8. This works out to be negative 1 squared is 1 minus 2 minus 8. This is equal to negative 9. Okay, so our vertex is going to be negative 1, negative 9. Okay, our axis of symmetry is the vertical line that goes through our vertex. So that's going to be x is equal to the x coordinate of our vertex. X equals negative 1 is going to be the axis of symmetry for this line. Okay, so this is our vertex and our axis of symmetry. Just gonna box this off here. This is like important. Okay. The second thing we want to evaluate is a positive or negative. A is 1, so it's going to open upwards. It's opening upwards with a vertex at negative 1, 9. At this point, we probably want to find some other points. So I go 1 in each direction. So we're going to do f of 0, and that is equal to 0 squared plus 2 times 0 minus 8. So this is equal to negative 8. So we have a point that's 0, negative 8. I usually start at my vertex. I go 1 in one direction, 1 in the other. So we're going to do f of negative 2. Again, this is negative 2 squared plus 2 times negative 2 minus 8. So this is 4 minus 4 minus 8, which is equal to negative 8. So we have a point here that's negative 2, negative 8. So we see the symmetry there. And I'm going to go 1 more in each direction, or I'm just going to do f of 1. So we were at 0, we're going to go one step up. F of 1 is 1 squared plus 2 times 1 minus 8. So this is equal to 1 plus 2 minus 8, which is equal to negative 5. So we have a point at 1, negative 5. Okay, so we're at a point where we can go ahead and graph this parabola. Okay, so we have a point that is negative 1, negative 9. That's going to be our vertex. It's also going to be our minimum for this graph. We have a point that's 0, 8, and we have a point, or 0, negative 8, a point that's negative 2, negative 8, that's here. We have a point that's 1, negative 5 right here. Right here. And we can use our axis of symmetry here. We know our axis of symmetry is x equals negative 1, so we can use our axis of symmetry to know that there's a point here as well at negative 3, negative 5. And now we can start to draw this parabola. I'm not very good at hitting my points on this computer screen, but that's the gist of it. So we have a vertex at negative 1, negative 9. We have an axis of symmetry at x equals negative 1. We've plotted a couple more points so that we have an idea of our graph. Okay, if you have any questions as you go through this section, please do not hesitate to reach out to the Academic Support Center. We're here during the COVID-19 shutdown via online tutoring, and we are in person once things go back to normal on campus at the Academic Support Center. Thank you.